Hi, so we are from Team 7 and this is Vidya Bharati Vasudevan. Now I'll go about explaining the project overview along with the problem statement and all these other things in the poster. So the problem statement is that currently in Phoenix Children's Hospital there is no direct way to convert multiple STL files generated by various medical devices into a single X3D file. So they have to use a paid software to convert it and follow multiple tedious steps. So as a part of this project, our task is to build a software that will directly take in multiple STL files as input and convert it into a single X3D file and display the corresponding image in a 3D viewer. Also, based on different parts of the human body, different STL files needs to be associated with different colors, which also should be reflected in the 3D viewer. So the viewer can also choose to rotate the image, change the center of the origin as per his requirement. So that is the problem statement. So but solving this problem is very important because currently the clinicians in Phoenix Children's Hospital have to use, as I said, paid software to convert the STL files into single X3D file. So this software that is developed by us will provide a single platform for them to upload and view the files without any additional steps required. So as this is a single tool to perform all the tasks, this will be much simpler for them to use. So the most important aspect of this project is that the tool developed by us will be used by the doctors and clinicians there to display 3D views of the cardiac images to various families of the patients to explain their conditions for better understanding by the patients as such. So this is our poster that we actually submitted, so I'll just go with this. So this will be our project overview, which is more or less similar to what I told now. So these are our requirements, like we upload multiple STL files and choose different color and view it in a image as a 3D viewer. And finally we can export the X3D file. So these are the basic requirements that we went about implementing, and this is our project architecture. So as you know, in the view side we had in the GUI side we had the login HTML and the home.html, which actually showed the application. So in the login HTML we got the credentials from the users, and then because we were using Java, we used the servlets to perform the functionalities, to validate the credentials and so on, and then let the user into the application. And so once that is done, in the backend we had tables for, database. In the database we use different tables for to store different information, such as the user information and the X3D files and so on. And so that will be our project architecture. And so obviously our sample input and output files are nothing but the input file is the STL file that was given both in the ASCII format as well as in the binary format, on which we worked on, and we came up with an algorithm to convert it into the corresponding X3D file that could be rendered into the website. So those are shown here. And this is a screenshot of our application, wherein you will go ahead and upload the various STL files and choose different colors, as I told already, to convert them into the corresponding X3D file.
Hi, I'm Monushreja, and now I'll go through the algorithm to convert the STL to X3D. This was the main requirement for our project, where we had to convert multiple STL files, both binary and ASCII files, into a single X3D file format. So first we will go through the corresponding file structures. This is how a sample STL looks, and this is how a sample X3D looks. The sample STL files are nothing but triangles with 3 vertices each. So our main task was to map these 3 vertices into the structure of an X3D file format. Now going through the algorithm, what we did is, first we have to follow these structures, like ignore the facet normal, iterate through outer loop of STL, and then take all the points from the vertex and convert it to double values with 0.5 precision. So this is how it should look. 64.39, 54.11 and 10.41 should become the same, but this time they don't have, they are of 0.5 precision. And next we will make the structure like +1 -1 -1. So 64, 54, 10 will become 64 -54 and -10, and so on. So like this we would convert the file, and then we will put these into the coordinate point tag of the XML, and we will also calculate the index facet set, and then map each unique set of triplet entry from vertex in STL to a unique integer starting from 0. This is how it will look. So at the end, what we will get is every general information, background details and translation information, everything will be added to the X3D, and all the values should come also in the X3D in the form of the XML. And at last we will export the X3D. So this is how we will be converting the multiple STL files into a single X3D file. Now Kallol will walk us through the application.
Hi, I am Kallol. I'm going to demonstrate the application. So our application, as you can see, it's login protected, so that only secured person from Phoenix Children's Hospital can access the application with a proper login credential. So once a person log into the system, the screen looks like this, where he can give the structure name. As my friends told earlier, that the STL files are nothing but the structural image of body parts. So the structural name and component names are the STL file names, whereas the browse option, people can browse the STL files. He can choose the color for the STL files, and there are some additional options that I will demonstrate later. And depending on the number of STL files, people can add number of rows, so to convert all the STL files combined together to a single X3D file. So for our demo purpose, we have 7 STL files to upload and convert it to X3D file. So in structure name, we are trying to depict a herd diagram. So we have 7 structure for herd. I give the structure name, I choose the STL file, and for the color section I can choose the variety of colors, and whatever color I have, the component name I'm keeping it as same as it is. And for the additional option, what I have is ambient intensity, shininess and specular color. So this ambient intensity and shininess will make that particular part of that X3D object a bit more shiny. Intensity will be more. These values can have any values from 0 to 1, where 0 is the lowest and 1 is the highest. So let me give these numbers. The specular color, I can choose any color from that. On top of that, I need to fill the other things here in structure window. So let me first fill those values, and then I'll do the submit to convert these STL files. So right now I'm just putting the structure names, and I'm just uploading corresponding STL files. So this is pulmonary arteries. I choose that file. This is right ventricle. This is left ventricle, left atrium, it's aorta, and this is right atrium. Okay, I can choose the colors again for individual component, which is very important, because to identify each of the different components separately, choosing color is very important. Almost I'm done. So I choose color for different objects, different separately. And so this component name is like when we have the X3D object converted from the STL, so for each of these objects they must need to have one name. So this component name will be there in our X3D object. So as of now I can keep it same as the structure name, and for the demoing purpose I am just changing I'm just giving additional option for 2 of these objects. it's there. So now when I submit, what it will do is it will take care of all the STL files uploaded. It will convert them, it will combine them together to a single X3D object, and it will show it here in the X3D viewer. So this is loading the X3D object. As you can see, our hard 3D object is there. I can rotate the object, I can zoom in I can zoom out, I can do whatever you want as a 3D viewer functionality that is properly involved. And this is not done with any paid software. This is only used on Java and HTML5. And here we have the option to export X3D to get the X3D file so that it can be used in some other softwares as well. Here we have also option for rotate the object. It will rotate the object at 180 degree. So this is kind of our demo. Thank you all.